All right, today we got transformations of sine and cosine functions. I'm going to go ahead and assume that you remember how to go and graph a regular sine and cosine function from the previous lesson. If you kind of know where the start and end points of these are, then that can kind of help everything go pretty well as far as the graphing goes today. So down below are going to be the generic functions for sine and cosine down below right there. So usually I like it in the factored format. So I'm going to go ahead and write that out right here, where it's kind of like you undistribute this b, because this will help us get our horizontal translation. And if you're to undistribute b, it's going to wind up being some c over b number inside of the parentheses, kind of like that. But this format right here is a little bit more useful, so we'll use that quite a bit. And there's a spot down below where we'll have that there. So A, B, and C and D are going to be constants, so that just means some type of number. And then A or B cannot be 0, because that would kind of mess things up. Now we'll have some different names for the terminology of the transformations: vertical compressions and expansions. We're now going to refer to that as the amplitude. Amplitude usually starts from the midline, and then it's how many units up or down the graph will go. A period is going to be, we learned that is how long it takes for one cycle. So when you start expanding or compressing your cycles, we'll just refer to it as a new period number right there. And then horizontal shift is actually going to be called phase shift. I think they use that in the science classes and stuff when modeling waves. So we'll call it a phase shift instead of a horizontal shift. But we'll say like phase shift of right pi over 6 or something along the lines of that. So if you need to pause to go get all that written down, you can, but I'm going to go ahead and move on. Also, sometimes we might talk about the midline. The midline is the line where the graph goes up and down from. Right there, there's usually some type of midline. Normally it's 0 unless we have a vertical translation. So down below, there's a couple little rules here. A is always going to be tied to the amplitude. That's easy to remember because it's A for amplitude. That number is usually out in front. Like I said, I usually like the factored formats of these here, so I honestly would not even look up here at the top too much at those because those aren't going to be as helpful. The factored format's the best. The period of these, there's a formula for it. It's always going to be 2 pi over b for sine and cosine, and then when we get to it, secant and cosecant as well, but 2 pi over b. Frequency, this is just a reciprocal of the period. Technically, it's 1 divided by the new period, but if you do 1 divided by the new period, it would just be b over 2 pi, so you just need to know that it's a reciprocal. The phase shift, I usually look at the simplified form right here, or the factored form right here. The phase shift is whatever the c over b numbers are going to be, and we'll see that in an example in just a minute, but it could go right or left based off of that. Vertical shift, that's the thing outside of the parentheses right there, so like a d value that move you up or down d, and then the midline is the equation y equals d. So that is everything you need to know there for those. So next, I guess we're going to go ahead and start graphing a couple of very simple transformed graphs right here. So now we are going to graph y equals, or gx equals 1/4 sine of x. We're going to compare the two here. So yeah, let's do this here. Let's recall back that the sine graph typically starts normally at 0, 0. If you know that sine starts at 0, 0, we'll be able to transform that there pretty well. So normally it starts at 0, 0, goes up, down, and then back up like that. That's kind of the basic shape of sine right there. So we're going to do that, but this time with the transformations, this 1/4 right here, that's your new amplitude. So the amplitude normally is 1. Now it's going to go up and down 1/4 unit. You could call it a vertical compression if you want, but most of the times they're going to say an amplitude of 1/4. So here's how I will typically do these here. On a graph like this, they don't give us any scale. Typically, the graphs that we'll see on our tests or quizzes is 12 tick marks are going to usually be 2 pi right there. So if you go count out 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 right there. This should be where 2 pi is located right there. And then I guess this will be 0. And if you want to label these other ones, you can. Pi over 2, pi, and 3 pi over 2. Okay, so I would use that scale on most of them there because that's how the tests and quizzes are going to be. That means each 1 tick, I'm not going to label this on everyone, but each 1 tick here is pi over 6. So go pi over 6, 2 pi over 6 next, which is pi over 3, and then pi over 2 after that. Okay, so I usually don't label those because it'll kind of get messy if you label every single one. But this right here is a good rule of thumb unless you have some type of horizontal stretch or shrink there. So, okay, and then from here, normally the sine graph goes up and down 1. To kind of help out with that, I'm going to label my y-axis like this here. I'm going to label 4 ticks being 1, and then we can really see the stretch happening. Okay, normally the graph, the way I kind of go and do the transformations here is I make a little box that we're going to fit everything in. So normally we start at 0, and then 1 full period is going to be 2 pi. The midline is here at 0. It's not going to change. And then normally sine goes up 1 and down 1. So what I do usually when I graph these is I fit the entire sine graph into this box here, because that box can change shapes here. It can go, it can be taller if you change the amplitude. It can be a little bit narrower. You can go and move it up or left and right. So, but if we have this little box sketched out, we can go and fit the entire sine curve in here. So the first one I'm graphing is I'm going to graph just, I guess here in purple, I'll graph this right here, sine of x, and then I'll graph the one with the 1/4, and then we can really see the difference there. So sine typically starts at 0, 0, and then it ends at 2 pi there at the end of the box. And then halfway in between those should be another point typically. Like, so if you kind of know the basic shape of this, this should kind of help you get the graph going. In between those zeros, it should hit its max and its minimum point, and then this would be 1 full sine curve right here. Those are typically going to be the only nice points that you got right there. That is 1 sine curve. Okay, you could actually, if you wanted, once you get a few points plotted, you can actually kind of use patterns here. It kind of looks like it's, well, hang on, I think I went down too low here. That's right. Yeah, there we go. Yeah, I didn't count very well there. I was like, yeah, that's not looking right there, but there you go. So we'll go down there, fix that up. And that should be its lowest point right there, if I count my scale out right. So kind of looks like every 3 to the right, and go up and down 4. You can go get some points, kind of like that. So if you wanted to extend it even further here, kind of like that, get a little bit more than 1 full curve, you can. You could even do that over here to the left-hand side if you wanted. And have it kind of curve back around there. Make sure you put arrows though at the end of those, because they will repeat forever. But inside of this box right here is 1 period worth of your graph. So that's the main sine graph. To get the one with the 1/4 out in front, now we are going to go up and down 1/4 of a unit, which is kind of actually why I went and made the scale the way I did right here. So now I'm going to fit everything kind of inside of this little box here. So we should have the same kind of shape, except it's all going to fit in that little box there. So just so it doesn't get too messy here, I'm just going to not sketch the little box. But now the zeros, those will stay at the same spots, but now instead of going up and down 1 full unit, you're going to go up and down 1/4 of the unit. And it kind of makes this flatten look there to your graph. And you can graph as many cycles as you want. Usually you need at least 1 full cycle there, and we could get a few more if we wanted, but that would be sufficient right there. So I like graphing them both at the same time sometimes so you can really see the transformations that are going on, especially when there's not many transformations. When there's like, 3 or 4 transformations going on, sometimes it'll get messy if you have both graphs. So I think towards the end, we're not going to graph everything there, but that's how you go and do those there. So everything's 1/4 smaller. So let's try out this next one here with the cosine graph. Here you got -3 cosine of x. And then we're going to find the amplitude, and we're going to sketch 2 periods, both functions, if we can fit it there. I don't even know if we might be able. Yeah, we should be able to fit it, actually. But yeah, anyways, here we go. With cosine, we need to remember the basic shape of cosine. Cosine typically starts at 0, 1 instead of 0, 0. And then usually cosine goes down, then back up, and then does one full cycle like that. So we're going to go ahead and give this one here a go. We'll do the same thing. I'm going to make every 12 ticks 2 pi. So there should be 2 pi right up there. If you want to go relabel like pi or pi over 2 and stuff like that, you can right there. But basically it's every 3 ticks should be pi over 2. So we'll use that scale on most tests and quizzes. So with this one, I guess we're going to have a vertical stretch here. Here's what I'm going to do here. I'm going to call this 1 and then 2 and then 3 because we're going to have that vertical stretch or that amplitude. The amplitude technically is regular 3, but then you also have the negative, so that will do a reflection across the x-axis. Okay. So a typical cosine curve usually starts at its highest point. I guess here I'll do it in purple. Highest point, and then at 2 pi, it should end at its highest point. And then halfway between those, it should hit its lowest point, which should be down here at -1. And then halfway between those should be the zeros. So there's a typical cosine curve right there. I'm just going to keep going down. I'll get a little bit more points in just a second. Now, if we want to do the amplitude of 3 right here, that means you're going to go up and down to 3, kind of like that. Okay, so it's going to go up much higher and lower. Also, instead of starting up here at 3, 0, there's the reflection, so it actually starts down here at -3, 0. And then when you do your full cycle, you should end there at -3. Okay, since it's cosine, halfway between those, it hits its, I guess, maximum point since the reflection happened there, and then halfway between those, it should actually wind up having the same zeros. So it'll kind of look like this. Okay, and then that is actually right there, if you kind of box it up here, that is one full cosine curve right there with our reflections. And since they wanted 2 periods worth here, I'm going to go ahead and just continue the pattern here a little bit. It's kind of looking like it's over 3 and then up and down 3. So I'll just, get a few more. What I had in the box would be good enough for 1 period. But you can follow your pattern and extend it a little bit off of the grid here. And that should be it. Make sure over here on this left-hand side you don't accidentally extend it. Make sure you don't draw it going up. Just make sure you go and draw it, turn into where it goes back down right there. And that should be the rest of that graph right there. All right, let's keep it going here. Let's start messing around with the periods and the phase shifts and stuff like that. So coming up here, you got this one here. I wanted to change it. We'll do one with a denominator in just a second, but I want y'all to change that to y equals cosine of 2x, just so we can kind of see how that's going to affect things. So normally this 2 right here, when it's next to x, this is going to be your b value right there. So normally your period formula for these here, for sine and cosine, is going to be 2 pi over your b. So in our case here, it's going to be 2 pi and then over 2, which means the period, the full cycle, should be pi. So remember, that means, like usually 2 pi is going to be 12 ticks long. So that means pi, if we're trying to figure out how wide to make our cosine graph here, it's going to be 6 tick marks wide. That's going to be for your period right there. If we follow that same scale. So here, I'm going to go ahead and start labeling everything here. Here's pi over 2. After 3 ticks, 6 ticks should be pi. That should be how long it is. Let's go ahead and put in the 3 pi over 2 and 2 pi as well. Like that. So normally, a cosine function, here, and I'll make it, let's make the scale, I guess it doesn't really matter. I'll make the scale here, I'll make it like that. I'll put 1 at 2 ticks right there. Doesn't really matter where you put them, but normally cosine typically starts at its highest point, and then it ends at its highest point after 2 pi. And then halfway between those, it should hit its lowest point, and then halfway between those points, you should have some zeros. This is the typical untransformed cosine curve. Okay, so now what we're going to do is we're going to kind of squeeze in our box. We technically have a horizontal compression by 2, which means our period's now going to be pi wide. So here's what I typically will do. I'll start this here. I'll start a little box going like this here. The left side of your box will be over here at 0, and then the right side of the box that I want to fit this into is going to be there at pi over 2. It's going to go up and down 1 because of the amplitude. And then halfway in between the up and down lines, there's a midline right there. So inside of that little red box, I need to fit in the entire cosine curve. Cosine typically starts at its highest point, so I'm going to put a point there. And then here's where it's a little different. This point that was over here to the right, you're now going to end that there at pi, or at the far right side of the box. And then what you can do from here, halfway between those 2 points, actually happens to be at pi over 2, halfway between, should hit its lowest point. And then halfway between those points should be zeros. It's actually, since it's 3 ticks wide there, you're going to have to do at like 1.5 tick marks is going to be where those zeros are going to be. And then when I sketch them out here and I zoom out, you'll be able to kind of see, compared to the purple graph right there, we squished it in, or we horizontally compressed it. Also changing the period. So that is just one period's worth right there. So you could, if you want to follow the instructions did say, let's see, sketch at least, well, they only said 1 period, so we're technically good there on that. But if you want extra periods here, you can go and follow your pattern, where it's now you got to be kind of careful. I guess it's every 1.5 ticks, you'll have something going on. At 1.5 ticks, you'll have another 0. At 1.5 ticks, a low point. 1.5 ticks to the right, another 0, and then 1.5 ticks, and a point like that. So you can kind of see another cycle there, kind of like that. And that just keeps going forever. Once you get one of the boxes drawn, you can extend your pattern infinitely left and right forever to get your graphs. So that is one like that right there. So it's got a couple of transformations. So, okay. Now, I guess, yeah, we can do this next one here. This one's a little off topic here, just writing an equation for a situation. Here in a second, we'll do some more transformations here, but I'll go ahead and do this here. You got musical notes are classified by frequency, which is actually tied into something that we'll be talking about, or we have already talked about. Frequency, remember, is typically b over 2 pi instead of 2 pi over b. So apparently middle C has a frequency of 262 hertz. Hertz are oscillations per second. Use this information to write a sine function that can be used to initial the Behavior of the sound wave associated with middle C having an amplitude of 0.2. I think the amplitude typically is tied into like how loud something is, so maybe a bigger amplitude is a little bit louder. But the frequency is what we're going to kind of focus in on. So something like this, to write in your own equation, what I'll do is I'll take that frequency, 262, which is what we already have, and then I'm actually going to do B and then divide it by 2 pi, kind of like that. And if you want here, I guess you could go put 262. You could put it over 1, and then we could go and then cross multiply like we did back in algebra 1 right there. So it's 1 times B is B. 2 times 262, I guess, is 524. And then you'd have that in terms of pi right there. You could get the decimal for it. A lot of times we usually keep this in terms of pi. And then since that's our B that we just found, we can plug that in. And then they also told us A was 0.2. So once you get your A and B values, you can actually just write your own sine function here. So I'll go y equals 0.2, or 0.2 is fine as well. And then sine, and then we just found out B was 524 pi, and then T, I guess T for time right there. Kind of like that. And that would be your equation. I don't even think you need technically your parentheses around T, but that is how you go and write your own equation for something like that. Okay. All right, next coming up here, we just have multiple transformations going on, so we got a small handful more of these. With this one here specifically, this one's got multiple transformations, so we're not going to graph the parent function because it will get a little bit crammed in. So yeah, let's go ahead and run through this here. The biggest thing with this one here, there's actually kind of a common error, and I'll put a star next to this, is you need to have this in factored form. The factored form helps us get the correct phase shift, or the left and right type of movement. Because some people are going to say that's right pi over 2, but it needs to be in factored form for us to be able to tell what it's actually going right as. So here's how we do this here. We undistribute 3 like this. Some people will put like an extra little bracket around that. If you want, you can. And then if we factor out 3, it's like we're dividing. And we need to be a little careful here. I'm going to go off to the side here. If I'm doing pi over 2, and then I need to divide by 3, I'm going to go and do keep, change, flip, and I'm going to rewrite that as pi over 2 times the fraction 1/3. And when you multiply that, that actually comes out to pi, 1 times pi in the top, and then 2 times 3 in the bottom, pi over 6. So this actually moves right pi over 6. That's the biggest error with this here. This is right, that's the phase shift, right pi over 6, not pi over 2. So be kind of careful there on that. Very, very common error. Okay, so next we're going to go and, I guess we need to figure out the period. The period is going to be 2 pi over the b value. The b value, regardless of what format, you should tell me that is 3. So the way I go and figure out, like, okay, how wide do I make 2 pi over 3? Because some people will like literally go and try to figure out where 2 pi over 3 is by counting up the ticks. The way I do this here is I still will label this where it's 12 ticks is 2 pi. Just like that. And then I think about this here. If I take 12 tick marks and divide by 3, that means 2 pi over 3 is 4 ticks wide, based off of the scale that I'm choosing. And this helps me line everything up well enough here. So it's 4 ticks wide, but you got a phase shift here. You also have a phase shift. It goes right pi over 6. Based off of this scale that we have, pi over 6 should be that first tick mark. So it's 1 tick is pi over 6 right there. So we're going to start this whole graph here at right pi over 6. I'm going to actually put a dotted line. That's going to be the start point right there. So we're going to start it there. That's going to be like, if we're doing a box, I'm going to start the left of the box right there. Okay. Then, since it needs to be 4 wide, I'm going to go right 4 from pi over 6. 1, 2, 3, 4. And then I'm going to put another dotted line. Okay. And those aren't like vertical asymptotes like when we're graphing tangent and cosecant stuff. Those are just the left and right edges of the box. The amplitude, by the way, if we go back and look at it, there's no number written, so it's implied to be a 1, meaning you're going to go up and down 1 from there. You can change, or whoops here, -1. You can change the y-axis scale to whatever you want there. I typically, we'll do 1 or 2 ticks right there. So that means, if that's your amplitude, that means the top and bottom of your box should be right there. So inside of this little box right here, you should be able to fit in your entire sine curve right there. And that's why I draw that box. I draw the box visually, and then once you kind of know the shape of sine, you can graph this real easy. Remember, sine, I think we wrote it on the first one, sine typically starts at 0, 0. And if you know it starts at 0, 0, that means it starts there, right there in the middle. The far left of your box will be at 0, and then the far right of your box will be at 0. And then halfway in between, if you look at your sketch we did, halfway between should be another 0. And then halfway between those should be its highest and lowest points right there. So you kind of cram in an entire sine curve right there. It got moved to the right, and then it also got squished in or horizontally compressed right there. And that right there, that is 1 period's worth. Now, if you go look at the instructions, they do say graph 2 periods worth of a function. So we can extend the pattern there. Once you get that one box drawn, you can extend it and get a couple of more points there if you want. You could even extend it the other direction if you wanted. Right there, I just got 3 periods worth right there. And that is how you go graph with the transformation. So it takes a little bit here, but if you use that box method that I'm showing you guys, it should go fairly smooth once you kind of understand how to move around the box. And understanding this stuff right here, this really helps. There's other teachers that will teach things like the start and end points and do something where they set things equal to 0 so some teachers will do that, but I think this box method, I've had a lot of students have success with it, so that's the way I usually teach it. So all right, I think we got 2 more here that we'll run with, and then we should be done. Also, just to add variation here, I am going to change this one to cosine. If you want to scratch that out, if you want to change that to cosine, just so we can practice another cosine graph here. So this one's got a lot of things going on. It's got, what do they want us to do? State the amplitude, period, frequency, phase shift. What do they want? I think I forgot the frequency on the other one. If you want to go back and get the frequency, frequency, you just flip the period. So 3 over 2 pi. Yep. So that would be everything. So now let's go knock this one out here. So say the amplitude. The amplitude is implied to be 1. It's not a number out in front, so 1 would be good there on that. Period. Period you actually can do right away. It's 2 pi over your b value. There's no implied number out in front of x. So it will stay as 2 pi, which means it's the typical width. Remember, 2 pi is 12 ticks. Okay, if we use the scale we've been using each time. The phase shift, usually I'll abbreviate it PS. The phase shift is going to be left. There's nothing, by the way, to factor out. I guess you could write it like this. There's nothing really to factor out. So you don't have to worry about so much on the factor form. The phase shift here is still going to be left pi. And then what else do we got here? Oh, and then a vertical shift, and that is up 1, which actually moves your midline. So I'm going to go ahead and now start labeling my x-axis here. So you'll have pi over 2 at 3 ticks, pi at 6 ticks, 9 ticks, 3 pi over 2, and then 12 total ticks is 2 pi. Because the graph is going left pi, I'm going to count out 1, 2, 3, 4, 5, and then just a little bit off here. Negative pi, or 6 ticks to the left, is where this actually should begin. Okay, and then let's see here. I'm going to put 1 and negative 1 right there. Okay, and then the midline. Okay, the midline is moving up 1. So I'm going to actually do like kind of like a little dotted line like this here. That's the midline. Not going to draw it, too much farther right because I don't need to go forever, right? I guess the left of the box that we're going to make is going to go right there at pi. And then if it's 12 total ticks wide, you can go count it, or from negative pi to positive pi should be where this thing ends. And then based off of my scale, it needs to go up and down 1, but up and down 1 from the midline. So I'm going to go up and down 1 from that midline that's already at 1. And then right there as well. Okay, and then let's think cosine. Cosine, typically, when we graph, it starts at 0, 1. That would be something good to kind of have memorize. Cosine starts at 0, 1. What does that mean? In our box, it should start at its highest point up there. And then it should, at the end of the box, end at its highest point. Halfway in between those, it should hit its lowest point. And then halfway between those points, it should have, I guess I shouldn't call them zeros, but it should intersect, I guess, the midline halfway in between those. They kind of would be zeros if there was no vertical shift. And there's one cosine curve right there. Obviously, we don't have much more room to the right, or I'm sorry, to the left, so we'll just draw an arrow there. If they want 2 periods worth, then I guess we can continue the pattern. It's kind of looking like over 3 and then up and down 2. And I think if I graph that there correctly, that should be the second full curve right there. And that's how you do it. So if you can get one box and follow the pattern, it becomes real easy. Yeah, I've actually seen some teachers, they'll just make a table and just go look at the unit circle every time. That takes forever, in my opinion, to me, is the most efficient way to go and graph everything. Now, the homework, too, they'll do things where they'll ask for things like the new domain, the new range. So you'll need to be able to kind of look at those and figure that out, like your new domain. Well, I guess domain negative infinity to infinity, but your range now is going from 0 to 2. So they might ask you little things like that, so be ready for it. All right, the hardest one here. At the end here, they kind of got a little bit of everything here. They got a new amplitude. They got something going on with the period. They got a phase shift. They also have a vertical shift. So quite a few things going on here. The first thing we need to do is actually get this in factored form. This is technically not in factored form. So factored form would look like this: 1/2 sine. Technically, your b, watch out on this, b is technically 1/4. So that's going to affect something here with the period in just a moment. So we need to factor out or divide by 1/4. So when I do that, we need to take that pi over 2. Watch this here. We'll do pi over 2, and we need to divide by 1/4. And because of keep, change, flip, that's actually going to be the same thing as timesing by 4 right there, which means that this will be 2 pi. So when you write it in factor form, your b is 1/4. And then you have x, and then minus 2 pi. So that kind of looks weird there. And then minus 3. So if you were to distribute the 1/4 back in, you should get this same thing that you have above. But I like the factor form because you can look right at the factor form right away and tell what the phase shift is. So I guess we'll get to that here in a second. The amplitude is going to be 1/2, the number out in front of the sine function. The period is typically 2 pi over your b, 2 pi divided by 1/4. We do need to do keep, change, flip again. 2 pi times 4 over 1 would actually be 8 pi. Okay, which means 8 pi, that's pretty wide. You know, if 2 pi is it's 12 ticks, 8 pi is going to be 4 times that. It's going to be 4 times as wide. So we're going to have to kind of mess around a little bit with the scale, unfortunately, on this. Occasionally it'll happen once or twice in the homework. But what else we got here? We got right 2 pi. And then our midline is moving down 3 total units. So I would not use the scale of 2 pi being 12 ticks, because that is going to be too wide here on this. So we would have to come up with our like kind of a newer scale, I guess, to go with this here. I would personally recommend make each tick mark pi, which means every 2 ticks you could say it's 2 pi, 4 pi, 6 pi, and then 8 pi. Okay, that will make it kind of to where we can graph it a few times here. Okay, I'm going to make every 2 ticks on the y-axis. I'm going to make those every 2 ticks 1 unit. So there's all those. I think we should be able to get everything to fit in here now. So remember, our phase shift was right 2 pi, so that's going to be the left edge of your box. And then the whole thing is 8 pi wide here. If you go count it up here, I think 8 pi is 8 ticks. So I need to make this box 8 ticks wide, which I think goes over here to 10 pi. So I'm making it 8 ticks wide because I changed the scale on that x-axis. Midline. The midline is getting moved down 3. So I'm going to go down here to 3 and draw the midline. And then the amplitude was up and down 1/2. And conveniently, I made each one box, one tick mark, a half. So it'll go up to that half unit and then down a half unit. And inside of that little box that I just made right there is where we should fit the entire sine curve. Now, by the way, too, sometimes we'll throw in like a negative out in front. You would need to make your sine curve go down if they were to add that. But here we're good to go. So, all right, so in that box, if you know what sine looks like, sine typically starts at 0, 0. So inside of that box, you should have something that kind of is looking like that. That means at the far left, you should have a point, and at the far right, you should have a point. Halfway in between, you should have a point. And then halfway between those, you should go up and down to the max and midpoints. So once you get that box drawn, once again, it's super, super easy. You just got to kind of know the shape of your graph and then how to get this box drawn, and then you can continue the pattern if you need 2 pi's worth. And there you go. You can extend it, draw arrows there. So that is it there for your lesson here today.